Hello, Algebra 1 students. In this section, we're talking about special factoring techniques. So what we talked about in 10.5 and 10.6 was factoring trinomials and factoring trinomials with um, a coefficient that's not 1. So what we're going to be talking about today is a few different types of polynomials that we can use some cool rules to help us factor. All right, but before we do that, let's just go into a review of multiplying polynomials. So again, this is something that we've already done earlier in the chapter. All right, so multiply the polynomials together. We're just going to FOIL. So we multiply m and m to m squared, and then we do m times 3, so 3m. Negative 3 times m is negative 3m. And then finally, negative 3 times 3 is negative 9. All right, those middle terms are going to cancel, so we're just left with m squared minus 9. Okay, so this is that sum and difference pattern that we talked about. All right, so same idea on the left here, or on the right now, we have this also a sum and difference pattern. Okay, we multiply those first terms together. So we have 25y squared. Multiply the outside terms, negative 30y. Inside terms, positive 30y. And last terms, negative 36. All right, so because we have that sum and difference pattern, we're always going to get that these two terms in the middle are going to cancel. So we're just left with 25y squared minus 36. So let's take a look at this a little bit more in depth and kind of unpack what's really going on here. Okay, so factoring difference of squares. Okay, all factoring really means is unfoiling when we're factoring trinomials and difference of squares here. So the characteristic of difference of squares. Okay, the two terms are perfect squares. So that means this w here, w squared, because it's something squared, it's a perfect square. And 100 is also a perfect square. So the two terms are perfect squares. Okay, and they are separated by a subtraction sign. All right, so difference of squares, we are subtracting two perfect squares. That's what it means. All right, and the factored version of this, the factored answer, the terms in these parentheses are the square root of the terms in the problem. So notice that w is the square root of w squared, and 10 is the square root of 100, okay? And there's always one addition and one subtraction sign. Okay, there's always an addition sign and a subtraction sign in the factored answer. So if we understand this, if we understand that the factored answer is just the square root of the first term and the square root of the second term, and that we have a one subtraction and one addition, okay, we can kind of use that to make factoring difference of squares pretty easy. So let's take a look at this first example. All right. So what is the square root of the first term? So the first term is h squared. The square root of h squared is just h. So we have an h here and an h here. And remember, we're always going to have one addition and one subtraction. Okay, so that's kind of the setup right there. Okay, the square root of the first term, we add in that plus and minus. And then we ask ourselves, what's the square root of the second term? Okay, so the square root of 121 is 11. So we put 11 there and 11 there, and then we're done. Okay, that's all that we have to do for that one. All right, so let's look at the next one. Okay, I'm going to set up my parentheses. So what is the square root of that first term? So we have 49t squared. All right, the square root of 49 is 7. The square root of t squared is t. So we have a 7t here and a 7t here. All right, and then we're going to be adding and subtracting in 1. All right, and then we're going to ask ourselves, what's the square root of the second term? All right, 100 is a perfect square, and x squared is a perfect square. Okay, the square root of 100 is 10. The square root of x squared is just x. Okay, so we have 10x and 10x. All right, and that's all we have to do for this first one there. All right, let's look at the third example. Okay, remember, we are factoring difference of squares, all right? And do we have a difference of squares? Remember, difference means subtraction, all right? So no, we don't. Okay, we're adding these. So y squared is a perfect square, and 16 is a perfect square, but this isn't a difference of squares, so we can't factor this, so this doesn't work. All right, moving on to the last example for this section of the notes. We have x squared minus 25. All right, x squared is a perfect square, 25 is a perfect square, and we're subtracting them. So we do have a difference of squares here, so we can kind of use that, that pattern that we've been using. The square root of x squared is x, so we have an x here and an x here. We know we're going to be adding in one and subtracting in the other. Okay, so that's the first step. And then we have to find the square root of that second term. So 25, square root of 25 is just 5. So we have 5 here, 5 there, and then we're done. All right, let's move on to that second part of the notes. Okay, so we talked about difference of squares, and now we're going to talk about factoring perfect square trinomials. All right, so we have x plus 5 squared, so that is x plus 5 times x plus 5. Okay, we FOIL here, so we multiply those first terms together, we have x squared. Multiply the outside terms, you have 5x, plus multiply the inside terms, also 5x, and then the last terms, 25. Okay, so whenever we're squaring, a binomial like this, these middle terms are always going to be the same, and we kind of talked about that in a previous section. All right, we combine those, we get x squared plus 10x plus 25. Okay, so notice that our answer is a trinomial, and this is known as a perfect square trinomial because we're squaring something to get our answer. Okay, so again, in an example 2, we have a binomial squared, so our final solution is going to be a perfect square trinomial. All right, so we have 2y minus 3 squared, so that's 2y minus 3 times 2y minus 3. Multiply those first terms together, we have 4y squared. Multiply the outside terms, we have negative 6y. Inside terms, also negative 6y. Okay, those two terms are always going to be the same when we're squaring a binomial. And then we have negative 3 times negative 3, which is positive 9. Combine like terms, we get 4y squared minus 12y plus 9. Okay, so this again is known as a perfect square trinomial. All right, and in this part of the notes, we're going to talk about how to factor perfect square trinomials. Okay, again, factoring just means we're going to unfoil it basically. So let's talk about a few characteristics of a perfect square trinomial. So that's what the PST means, perfect square trinomial. All right, the first and the last term, or the first and the third terms, are both perfect squares. Perfect squares. And then the second term, okay, that middle term there, that 14x in this example, okay, is 2 times the product of the square root of the first and third terms. Okay, so just to break that down a little bit, it's going to be 2 times the product of the square roots of the first and the third term. So like we said before, the first and the third terms are always going to be perfect squares. All right, so the square root of the first term is just x. And the square root of that third term is 7. Okay, so this is 2 times the product of the square roots of the first term. So the square root of the first term is x. Square root of that third term is 7. Okay, so that's really 2 times 7x, and 2 times 7x is 14x. All right, so let's look at the factored answer. Okay, the term in the parentheses are the square roots of the term in the problem. So the term in the parentheses are the square roots of the terms in the problem. And again, that's the square root of the first term and the third term. All right, and the answer, okay, in the factored answer for any perfect square trinomial is going to be a binomial squared. Binomial squared. and the sign is going to be determined by that middle term. So by the middle term. All right, so if we look at this example that we have already written for us, okay, this middle term, 14x, is positive, so in our factored answer, we're adding. All right, if this middle term was negative, we'd be subtracting here. All right, let's take a look at a few examples. It says factor each trinomial completely. Make sure we check for the characteristics. Okay, so let's check here. All right, that first term and the third term are both perfect squares, and that second term, that 10m, is 2 times the product of the square roots of the first and the third terms. So the square root of the first term is m, the square root of the third term is 5. So 5 times m is just 5m, and 2 times that is 10m. Okay, so we have here a perfect square trinomial, right? And so to get our factored answer, we're just going to take the square root of that first and third term. Okay, so the square root of the first term is m, and the square root of that third term is 5. Okay, and we're squaring this. And again, that middle term is going to determine the sign. So we look at that middle term, we look at 10m. Is that positive or negative? Here it's positive, so we put an addition sign in there. So let's look at the second example. We have w squared minus 22w plus 121. Okay, so let's take a look at the first and the third term. All right, so w squared is a perfect square, and 121 is a perfect square. And if we take the square root of w squared and the square root of 121 and multiply them together, we're going to get 11w, okay? And 2 times that is 22w. Okay, so we do in fact have a perfect square trinomial here. And the factored answer for a perfect square trinomial is going to be, the terms in parentheses are going to be the square roots of the first and the last term in the problem. Okay. So the square root of w squared is w. The square root of 121 is 11. And then we look at that middle term, okay, and ask ourselves, is it positive or negative? And here it's negative, so that means we have subtraction and subtraction. Okay, and we can double check to make sure that this is actually going to work here. So negative 11 times w is negative 11w, and then w times negative 11 is also negative 11w. Add those together, we get negative 22w, which is exactly what we have up here, so we know that this is going to work. All right, and then since this is w minus 11 times w minus 11, they're the same, we can write it as w minus 11 squared. So let's take a look at the third example. So we want to ask ourselves right away, let's look at the first term and the third term. Okay, are they perfect squares? So the answer to that is yes, they both are perfect squares. So when we factor this, okay, we're going to look at the square root of the first term and the square root of the third term. All right. So the square root of that first term is 4y. So I'm going to write 4y here and 4y here. And the square root of that second term is 5w. So 5w and 5w. And then to determine the sign that goes here, we look at what sign that middle term has. And so since it's negative 40yw, we know that that has to be negative and that has to be negative. So let's just check our answers here to see if we're going to actually get that middle term. So we'll start by doing negative 5w times 4w, so that gives us negative 20yw. And then we're going to do 4 times negative 5w, which also gives us negative 20yw. We add those together, we get negative 40yw. Okay, so that works out. So because that works out, we can write our final answer as 4y minus 5w squared. All right, finally, we'll look at the very last example of the notes here. We have 16 squared plus 24x plus 9. So let's check. Is 16x squared a perfect square? Yes. Okay, is 9 a perfect square? Yes. So let's try to factor this and see if this will give us our middle term. So what's the square root of 16x squared? Well, that's 4x. So 4x goes there, and the 4x goes there. And then what's the square root of 9? Okay, the square root of 9 is 3. So the 3 is going to go there, and the 3 is going to go there. And then to determine the sign that goes in between both of these, we look at our middle term. And since it's positive, we're going to have a plus and a plus. All right, so let's double check to make sure that we're going to get 24x for our middle term there. So we're going to do 3 times 4x, that's 12x, and then 4x times 3, and that's 12x as well. We add those together, we get 24x. Okay, so that checks out. Okay, we get 24x. So that means we can write our final answer as 4x plus 3 squared. So all we're really doing for these is checking, is that first term a perfect square? Is that third term a perfect square? If it is, then we write our factored form, then make sure that we're getting that middle term. And if we do, then we can finally write our answer as a binomial squared.